Section 8.4 talks about arc length and area. Arc length is the part in red. If you have a circle, you're basically looking for the measurement around the arc. The formula is S equals theta r. So arc length is equal to the radian number times, or the radian number for theta times r, which is the radius in length. So for this particular problem, it says find the arc length given the radius is 4.78 inches, theta is 3.25 radians, and you're looking for S. S is the arc length. So since theta is already in radians, this is just a plug-in problem. Theta times r, so 3.25 times 4.78, and you get 15.54 inches. If you're looking for the area, notice how the area is in red. So the arc length is just that little section along the circle, where the area is all the colored in area. The area is 1/2 theta r squared. Again, theta has to be in radians, and r is the radius squared. So as an example, find the area given theta is 218 degrees and r is 5.25. You're using the area formula, 1/2 theta r squared, but the issue on this is theta must be in radians, and the problem gave you theta in degrees. So when they give you theta in degrees, you have to convert it over to radians. So 218 degrees times pi over 180 degrees is going to give 3.8 radians. Now plugging in, area is 1/2 times 3.8 times 5.25 squared. First I square 5.25 to get 27.56. Then I multiply 27.56 times 3.8. Then I divide it by 2, because 1/2 of a number is divided by 2. I get 52.39 square inches for area. The next problem, given the area is equal to 0.0214 square feet, theta is 321 degrees, find the radius. So this one I have to work the formula backwards, but first I'm going to convert my theta to radians. So I take 321 degrees multiplied by pi over 180, and I get 5.6 radians. So again, 321 times pi divided by 180 gives 5.6 radians. The area formula is 1/2 theta r squared. If I multiply both sides by 2 to move the half over, that gives me 2a equals theta r squared. I'm solving for r, so I divide by theta. That gives me r squared is 2a over theta. Finally, to get rid of the squared, I have to take the square root of both sides. So I get r is equal to the square root of 2a divided by theta. So once I have that formula reworked, I just plug my numbers in. So the radius is going to be 2 times the area. The area was 0.0214 divided by theta. Theta's 5.6 radians after I converted it. So I do 2 times 0.0214 divided by 5.6, press the equal button, and then take the square root. So I'm taking the square root of 0.0076, and I get my radius equal to 0.0874.